Hi there. This is a video about solving linear systems of equations using the graphing method. Now, when I'm talking about a linear system of equations, that means that I have two lines and I'm finding the intersection of those two lines. And when I have two lines on a graph, let's draw a graph real quick. Any graph will work, x, y axes. And let's say that I have one line and then another line. What I'm looking for is this point of intersection. This is my solution to a system of equations, okay? And when I have a point on a graph, remember that this is a point x comma y. Okay, so your solution will have an x value and it will have a y value. Okay, and that's the goal. We're solving for two variables. So let's continue that. We're going to solve for two variables. All right, and that's the idea. Now, in this instance, we're using the graphing method, so there will be no algebra involved. That will be later on when we use the substitution and the elimination method. All right, so let's look at a quick example. Okay, so in this example, we have two equations. I've got y equals 3x plus 2 and y equals negative x minus 6. Now, both of these equations are going to be lines on a graph, okay? These are in the form of y equals mx plus b. So in each of these, I can identify my slope and my y-intercept. So in this case, my slope for this first one is 3, and my y-intercept b is 2. All right, for this one, my slope is a negative 1, and then my y-intercept is a negative 6. And what I want to do is graph both of these equations on the same graph to find out where they intersect. All right, so once we've drawn a graph, I want to graph this first equation. So I'm going to take my starting point, which is at 2 on my y-axis, and I'm going to plot my y-intercept of positive 2, and then I have a slope of 3. And really, remember, we have a rise over run, so this is 3 over 1. So I'm going to go up 3 over 1. So I'm going to go up, start here, 1, 2, 3, go over 1, and then I'm going to plot a point. Okay, and I can also go down 1, 2, 3 over 1, 1, 2, 3 over 1 as well. And I get this line. Okay. And that's what I've got. All right, so that's my first equation that I've graphed. All right, now I'm going to graph my second equation. I have a y-intercept of negative 6, and I have a slope of negative 1. So let's first plot my point for negative 6. 1, 2, 3, 4, 5, 6. That's my y-intercept. That point's going to go there. And then a slope of negative 1 means I'm going to go up 1 over 1. And remember, we've got four kinds of slope here. I've got a positive slope, I have a negative slope, I have a zero slope, and I have an undefined slope. So remember, if I have a negative slope, it's going to go in this direction. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And do that stair step to generate more points. And I'm noticing where they intersect is right there, up 1 over 1. All right, so now I'm going to draw this line here, okay? And that's my second equation. And what I'm looking for is the point of intersection. And this point I also call my happy place, okay? And that's where that point satisfies both equations. And that's my solution, okay? So here's my solution to this equation. And so what I have is that's going to give me the point negative 2, comma, negative 4. All right, so I just have to locate that point on a graph, and that's my solution. Now, another way to check your solution for this is to actually plug in these values into my original equations, and it should work out for both of them. It should both be true. So let's do that real quick. All right, so the whole point of this is to check to see whether or not this point is a solution to this equation and a solution to this equation. Okay, it has to work for both in order for it to be a solution to the system. So what I'm going to do, remember that each of these points contains an x value and a y value. In this case, x is equal to negative 2 and y is equal to -4. And my goal is I'm going to plug these into each equation and see what I get, okay? So I'm going to plug in -4 for y here equals 3 times x. I'm going to substitute -2 in for x and then add 2. So at this point, what I want to do is I want to just do the math and see if we get a true statement. So 3 times -2 is going to give me a -6 plus 2. -4 equals, now -6 plus 2 does in fact give me -4. -4 equals -4. This is a true statement, so it works. Okay, now let's do the same thing over here. Now this part's a little weird. I'm going to plug in -4 for y, and then -x. When I have -x and I'm plugging a -2 in for x here, I've got -2 and then -6. So I've got -4 is going to be equal to a +2 minus 6. And I don't really need that plus symbol in there, but just to show you, I'm going to erase that real quick. So I have 2 minus 6, which is going to also give me -4. And -4 equals -4. That's true. All right, so since this point, since this x value and this y value works for both of these equations, it's a solution to the system. Okay, so I always check all these with Desmos. Because, Desmos is your friend on these types of problems, okay? Okay, so lastly, I want to talk about there are 3 types of solutions that you can get here. The first is the ones that we've been talking about, and that's when you have 2 lines that intersect and have intersect at one point, okay? This is one solution, okay? You could have another example where you have 2 lines that are parallel, so you would have no solution, okay? And because they don't intersect, okay? These are parallel lines, okay? Lastly, you have one where if you have one line and then you have another line that is directly on top of it. Okay, let me use a different color to show that. All right, a line that's directly on top of that, then you have infinite solutions because at any of those points, you have an infinite number of intersection points. So infinite solutions, and this is the same line. Okay, over here, this is intersecting lines. All right, so those are the 3 kinds of solutions that you could have with a system of equations. Hope you enjoyed this video, and we'll talk to you soon. Thanks. Bye.